Welcome back, friends. I hope you have enjoyed the first lecture of on ITS. In this lecture, we are going to now introduce you to some of the basic taxonomy in ITS, break down the ITS into its different components, tell you about how vehicular communication happens, and also give you an understanding of big data usage in transportation. When we are talking about ITS, we usually are talking about at three different levels, right? We are either talking at the level of the vehicle, or the level of the infrastructure, or at a cooperative level. So, when we are talking at a vehicular level, we are talking about technology that can be deployed within the vehicles, including sensors, processors, as well as displayers, which provide information to the driver, right. So, there are various cameras that can be fitted within a vehicle. There could be sensors that allows the vehicle to not sway too much in the lane, left or right. There could be parking sensors, right. Many of the vehicles now you would have seen has when you put a vehicle in reverse gear, it has a camera at the back of the vehicle that allows you to see how much space is there, and you can then back into a parking space. So, there are all of those systems that are in the vehicle are the vehicle level classification of ITS devices. Next is the infrastructure level, which are all the sensors that are on and by the side of the road that collect information about traffic, right. So, it can be your signals, it can be at the toll plazas that where your transactions are happening. So, all of those kind of devices that are either on the side of the road or on top of the road collecting information about traffic are known as infrastructure level ITS devices. And then there are cooperative level, which is the communication between the vehicles and between the infrastructure and vehicles, right. So, then there has to be also it is one thing to have just a vehicle level or an infrastructure level ITS capabilities, but unless and until there is communication between the vehicle and the infrastructure, your efficiency is most likely not going to be achieved, or higher efficiency is not going to be achieved. So, there has to be certain two-way communication between your infrastructure and your vehicle. And so, for example, in the last lecture we have told you that how two-way communication can be achieved of an ambulance or an emergency vehicle at a signalized intersection, right. So, the signal detects the vehicle, that is communication from the infrastructure of the vehicle, and then the vehicle communicates back saying, I am an emergency vehicle, give me right of way. So, then that is communication from the vehicle to the infrastructure, and then the infrastructure turns and the signal turns green. So, that is kind of two-way communication. So, that kind of communication is the cooperative level ITS devices. When we look at the classification based on three phases, what we see is there are users on one side, and then there are all the strategies and the planning segment on the other side, right. So, users want to have an efficient transportation system. Governments, agencies want to devise their policies, develop their priorities based on the existing system, and in between are all the different ITS architecture that needs to be developed in order to satisfy both ends, both the users as well as the planning agencies or the government agencies, right. So, when you look at an ITS, and we'll give you an understanding of what is a logical architecture and what is a physical architecture. These are basically how your information flow happens. What are all the hardwares and the softwares that are needed in order for a system to be created, right. Should the information be only one-way flow, should it be only two-way flow, what kind of information should be shared between the different stakeholders, so on and so forth. So, all of this is a very interesting new field, a new arena in which into which transportation professionals are getting into, like I said in the previous lecture as well, and this should be something that opens up newer avenues for you as well. So, for example, this is we have already told you about what a traffic management center is. The one in the previous lecture that we had showed in Bhopal is the first traffic management center that has opened as a part of the smart city. So, if you were to understand if you were to understand how information flows between the traffic management center and various other entities, you would have to develop something called a physical architecture, which shows the traffic management center and how it is linked to the roadway, right? What information is the traffic management center sharing with the roadway, and what is the roadway sharing back with the traffic management center. Furthermore, how is the roadway then connected to the driver as well as to the vehicle that the driver is in. So, what information is the roadway getting from the or giving to the vehicle and giving to the driver. So, is it getting back anything? It does not seem to be getting any information back from these. So, it is a one way type of information that is being given. Similarly, roadway network condition information is going out from the traffic management center to the different ISPs, right. So, Google and all are getting all the information about the roadway network condition from these TMCs, and it is a one way information that is going out. Similarly, there is a lot of one way information that is maybe coming into the TMC is the maintenance and construction management. So, suddenly there is a roadway construction that is going on in one part of the city. That information must be only coming in to the TMC, which is then maybe converting that TMC that information into some type of travel time or travel delay and then forwarding it to the information service provider. So, you see, in order to this is a very good diagram that is a very simplistic diagram that allows you to understand how how an ITS system may work. So, this is an ITS system, meaning this is an traffic management system, right. So, this is a traffic management system. How is it connected to the roadway? How is it connected to the basic drivers? How is it connected to the for example, media as well. So, if you have to provide information on the TV or on the radio about the traffic conditions, they can directly get information from the traffic management center. Traffic operational personnel can get information from this, and of course, different bus transit managements and also emergency management can get information on this. So, the basic thing to understand is who are all the stakeholders that need to get data, or from whom we need to receive data, what kind of data we need to get, and does the data have to be a two-way communication or one-way communication, and so on and so forth. These basic things, if one understands, then one would understand how to develop a ITS system for their city. What are the basic components of ITS's efficiency, right? How does it improve the efficiency in your urban traffic network? First is it allows you for automated data acquisitions, right. We have already given you a brief understanding of that. Automatic vehicle identifiers are nowadays used especially in public transportation arena, where you can you can have these AVI sensors on your buses, and you can easily locate where the bus is. Based on that, you can identify, you can put up information at various bus stops as to when the next bus is arriving, and so on and so forth. You can also use GPS technology, automated vehicle locators, AVL, which is provides fast, flexible, and relatively inexpensive data to determine a vehicle's position and velocity in real time, right. You can use that. Fast data communication to the TMCs. Now, once you have that, the data has to be now communicated to the TMCs as well. So, different types of communication protocols can be used. DSRC, dedicated short range communications, CAM, continuous air interface, long and medium range, and media to public like VMS, short messaging signs, right. You have VMS is nothing but variable message signs that you might have seen on the side of the road, saying that slow down, traffic ahead, or slow down, accident ahead, or something like that. That can be easily controlled. Those messages can be controlled from the traffic management center based on data that it is receiving from vehicles or incidents downstream. The other components of ITS efficiency is accurate analysis of the data. Now, when we are talking about all this data, remember we are talking about big data meaning large volumes of data. Now, from these large volumes of data, you have to make sense of what data, how much data you need, and only based on that data, that much volume of data, you have to convert now the data into information, right. So, it is not very efficient to just have CCTV cameras everywhere, right. You have to convert the feed of the CCTV cameras into some sort of information. So, if you have CCTV cameras and you are looking at the intersection, but you are still manually changing the signal timings, that does not help you improve the efficiency of that traffic signal, for example. Maybe all that information for traffic signal feed that you are getting, you have to then try to automate as to how to change the traffic signal automatically based on data that is coming. So, that is an example of what we mean by saying accurate analysis of the data, right. So, poor data has to be weeded out, data has to be cleaned, there will be a lot of noise in the data, some data are outliers. So, we have to check for the outliers as well, whether they are useful information or not. All that has to be done before so as to just establish whether your system is able to capture the current state accurately or not. Once it is able to capture the current state, for example, or in other terms, once it is calibrated, only then you can use it for forecasting traffic for different states, different traffic conditions, and so on and so forth. Next, it has to provide reliable information to the public as well as the traveler, right. So, just providing information is not good enough, it has to provide reliable information. For example, the next bus is arriving at 5:15 p.m. Now, if that 5:15 p.m. has to be reliable, if you do not provide reliable information, what usually tends to happen is the user will no longer have faith in what you are telling, and once that faith is lost, then the user may not use your services. That is one loss, or the bigger loss may be that the user may not use public transportation system on a whole, which is a bigger loss now that then he or she may be shifting back to the private vehicle, right. So, reliability of information is very crucial, that improves the efficiency, or that allows ITS to improve efficiency of a transportation network. Now, what are the different types of vehicle communications? We had already told you a little bit about it. Vehicle to vehicle communications, right. So, this vehicle is communicating to this vehicle saying that I am n seconds behind you, for example, right. I am n seconds behind you. So, maybe it is a time headway, what we call as a time headway. So, I am n seconds behind you. So, that is vehicle to vehicle information. Vehicle to infrastructure, communication between vehicles to the infrastructure. So, for example, this vehicle may be communicating to let us see, this vehicle may be communicating to a vehicle, a base station, or a mechanic, or to the TMC, traffic management center, saying that I am broken down, right. My vehicle has broken down, and this is my location based on cell phone towers, and I have to be I need some assistance at this location, right. So, this is communication from the vehicle to the infrastructure, to some infrastructure, for in this case to the TMC or to somewhere else, right. And then vehicle to everything, that means vehicle to any entity that it can influence it. So, it can send vehicle to vehicle, vehicle to infrastructure, vehicle to a pedestrian who is walking next to the vehicles, or to anybody who can influence the vehicle, right. So, there has to be, that is the ultimate aim, as to the vehicle should be able to communicate to anybody who can influence it. So, that is still We are still at a nascent stage in that. However, there is a lot of vehicle to infrastructure communication that is happening, vehicle to vehicle communication, some vehicle to vehicle communication is happening, and we'll tell you how it is happening. So, when we talk about vehicle to vehicle communication, it is usually happening through wireless networks, WPA networks, right, allowing vehicles in transit to transfer data on their position and their speed, right. Position and speed, these are the two data points that vehicles communicate. What happens is that, for example, a driver of a vehicle can receive a warning in the event of an accident risk, or the vehicle itself can independently take preventive actions. So, you may see that modern cars are coming with automated braking system, right, ABS. So, what it says is that if your vehicle gets too close to the vehicle in front of you, or if the vehicle in front of you suddenly brakes and is getting too close to you, your vehicle automatically acts. You don't have to put your foot on the brake, but the vehicle automatically brakes. Or there are onboard sensors, cameras, and radars that allows you to tell that tells you that a vehicle is too close on your right hand side. So, don't change your lane right now, right. Maybe your the vehicle is in your blind spot. So, do not change your lane right now. So, these kind of sensors are already in use in many of the vehicles, which allows you to have a safer driving experience, right. So, they improve the safety of your each of the passengers or each of the drivers, and in turn, so when safety is improved, in turn the efficiency of the entire network also improves. Vehicle to vehicle communication, the other thing is autonomous security systems, like we have already said, blind spot monitoring, automatic braking systems, automatic emergency brakes, lane departure warning systems. So, we have already discussed about these three things, and these are already some things that are available at the high end, in some of the high end models of the existing vehicles that are even available in India as well. Now, vehicle to infrastructure communication, V2I, components include RFID readers, traffic lights, cameras, lane markers, street lamps, signages, and parking meters, right. So, parking is something interesting that is happening in some of the urban areas as well. You can have on street parking that can be monitored using information using vehicle to infrastructure communication. So, on street parking lanes are created, on street parking zones are created, where when a vehicle enters into that zone, it is automatically sensed, and then there is a mechanism by which it gets your meter is starts automatically for parking price, and then based on how long you are parked, you can automatically get billed for your parking. So, this is something that is being used in the case of some of the cities that are looking at efficient parking management systems for their city. Wireless bidirectional and similarly vehicle to vehicle using dedicated short range communication frequencies to transfer data. DSRC is something that is very necessary in order to transfer data. V2I sensors can acquire infrastructural data and provide travelers with real time advice, right. Vehicle to infrastructure, the most prominent ones are your traffic signal that we have already discussed about, how the traffic signals can we can significantly reduce the presence of traffic police at a signalized intersection by using such ICT devices. Traffic supervision and management systems can be used can use the data collected from the infrastructure and vehicles to set variable speed limits and adjust signal phase and timing, right, to achieve fuel saving. So, based on the arrival patterns that you see through your CCTV cameras at the TMCs, you can then set your traffic signals more efficiently. So, that is what we have already mentioned to you about converting the data that you are getting, the feed that you are getting from your CCTV cameras into information, and then processing that information and using it to forecast what your travel time or travel speed or travel delay is going to be on the corridor. So, that is something that is very crucial, and ICT can help improve the efficiency of or help improve the efficiency of a signalized intersection vis-a-vis reduce the delays at such intersections. Vehicle to X, vehicle to everybody, vehicle to vehicle and vehicle to infrastructure communication models mentioned earlier are completed in the V to X, which represents a generalization. Data transfer from a vehicle to any entity that can influence it, or vice versa, vehicle to pedestrian, vehicle to roadside, vehicle to device, vehicle to grid. So, this is something that is being still worked upon. This can alert a passenger, a pedestrian, for example, who is trying to cross a street at an unsignalized intersection, and the vehicle can now communicate with the person who is trying to cross the street, and maybe send a message comes to his or her mobile phone saying that vehicle is approaching, please be alert. This is especially situations because we at an unsignalized intersection we usually nowadays are either have our headphones on, we are not looking at the traffic, and in such situations these things might be helpful, right. But these are still in a very testing phase, and this is something, if it becomes operational or if it becomes viable, can help in the safety of various safety of the transportation network as a whole. At various locations in our network, we would need to develop such warning systems for pedestrians. Now, when we talk about big data, let us give you an understanding of what we usually are trying to say. Big data, when we talk about big data, we are usually talking about mobile or cellular phone data. There are 3 V's associated with it. One is volume, right, large data set. One is velocity, high speed of data acquisition. The speed at which the data is generated and acquired is very high, and variety is a mixed data type. There is a lot of different types of data that is coming in. That is why we say big data, first and foremost that is needed in big data is data cleaning. What you may be getting, you may be, for example, you may be getting 100 pieces of information, but maybe all you need is 20 pieces of information, right. So, you have to screen the data and weed out those other 80 pieces of information, and then only look at the 20 pieces that you need. But in order to do that, you are not only getting 100, for example, like I said, maybe you are getting 1 lakh per minute, right. And if you talk about only 24-hour data, you may have huge data sets. So, you even just for working with 24 hours data and to clean up that data, it will take you a lot of computing, it will take you computing resources and computing knowledge that you need in your TMC or in your team will be very high, right. So, volume cellular phone data generated as a result of phones communication. One thing it gives you is the positioning of the various cell phones, right. Positioning meaning, right, you know all this. We have already talked about how cell phone towers and can be used in triangulation and trilateration to find out where an object is. Usually from your cell phone data, 2 types of data can be collected for transportation purposes, call duration record CDR or sighting data, right. We will tell you what each of those things are. CDR or call duration records usually gives you a lat long of your particular MAC ID, at what time that MAC ID was located at that location, and for how long your call went on for, right. So, through this information, what we can tell you, what one could understand is that nobody can trace it back to you, because see, all the personal identification features have been anonymized. Only we know there is a certain phone with a MAC ID of this, that started a phone call at this time, and that phone call lasted for 81 seconds. So, we can come to know about his or her call duration record. Sightings is whenever a cell phone is position detected by a tower, right. This is just sightings. You do not have to make a call in order to find out where you are. The cell phone towers can just detect if you have your GPS signal on your phone. The cell phone towers can just detect where you are based on again triangulation, right. So, this ID was detected at this time at that location based on triangulation. So, those are sightings. Sightings are a little bit more refined than CDR and can do a lot of temporal and spatial resolution. CDR usually you have to make a phone call in order for you to locate the person. In this case, you do not have to make a phone call, you just have to have your GPS signal on in order to be able to track, right. So, for example, what is then, so CDR and sightings data can be then converted into further information which the traffic or transportation engineers are usually interested in, is the origin destination data, right. We are always interested in whether a person is where a person is located and where he or she is traveling to. That is what our primary concern is. Our primary concern is whether he or she is located in residential zone, located in a commercial zone, located in a retail zone, and how long does it take him or her to travel between different zones. That is what essentially we are trying to find out. So, from the CDR data you can then find out different activity location in your city as well, right. For example, if you are seeing that this ID J0001 are making different calls during these times of the day, right, and from these same XY coordinate locations, right. So, usually what you can infer is that these are night times, evening 9 p.m., 10 p.m., 11 p.m., night, midnight, later in midnight. So, usually what that should tell you is that wherever this person, this location should be his or her home location, right. Usually a person usually a person would not be in his or her office such at a such later time in the day. Usually he or she should be at home usually, right. So, this is how now you have this ID's data for about a year or so, I guess, right. Once you have it for a year, and then you can generalize and see, yes, this may be his or her home location, or then you can have multiple of such IDs and then figure out where each of them their home locations could be. Similarly, if you have data during the day times, and then you can figure out during the day times J0001 is making different calls from a different XY location, maybe that location during the daytime could be his work location. So, so you see, now you have an information as a transportation engineer or a traffic planner. Now you have information about your origin and destination of your different users based on just cell phone data, calling data records, right. So, this is something that is improving vastly the volume of data that we are getting. Otherwise, in order to get origin destination information, we used to conduct only questionnaire surveys, and the sample size would always have to be would inevitably be always low. So, it not give very good information, but now through ITS devices or through cell phones, we are able to get larger volumes of data that can validate our claims from our questionnaire survey that we were getting, that can validate it, of course. So, like I said, the activity location home can be inferred because the frequency is 4 out of 7 records show that he or she is making these calls at these different times. So, with certain amount of confidence we can say that that is his or her home location. Now, how can sighting data be used? Sighting data can be used to convert or to determine the activity locations by something called distance based clustering. If you have taken or you are encouraged to take more and more statistical classes, especially if you are if you want to work in ITS, because this involves a lot of big data analytics, and statistics becomes more and more crucial in your ability to be able to work with such large volumes of data. So, distance based clustering, one of the methods is k-means based distance based clustering. What it essentially tells you is that if there are k points with initial centroids, certain centroids, and if these centroids do not change after forming newer clusters, then you can combine those points into one cluster location, right. There may be different points, but can you say that this is one cluster and this is another cluster, or can you say that, and do you want to say that this entire thing is a cluster? How do you determine what is a cluster? So, this k-means distance based clustering is a very simple method by which you can determine different clusters, and once you know different clusters, then you can say that this is a home cluster versus this is an office cluster versus this is a shopping cluster, and that gives you an understanding of origin and destination in your city, right. So, let us see an example that can allow you to simplistically allow you to understand how k-means clustering works. So, consider a sample of a weekday sighting data. The geographical lat long has been transformed into Cartesian xy coordinates. So, these are mostly xy coordinates for simplicity. The time is also simplified from Unix to HHMMSS. So, this is hour, minutes and seconds. Use k-means based clustering to group the sightings into two groups and determine suitable activity locations for the same, right. So, you have one ID, and for that one ID you have been tracking that one ID and seeing that it has been at these different locations during these different times. So, now you want to, based on this location data and time data, you want to see if there is any pattern, if there is any activity patterns that you can determine, right. If you can determine that they are at a home location or an office location, or what is happening and where spatially they could be. Spatially you already know that they are in different lat longs. So, can you determine conclusively based on this information that which is the home location and which is the work location. So, what first you do is you assign initial values of centroid, right. Just pick based on what is available here of these different lat long of these different Cartesian coordinates xy plane, in the xy plane, you just have initial values. Since k is only 2, you have said only 2 groups. So, let us assign 2 centroids. Let the first centroid be 1 1 and the second centroid be 7.57, right. And the superscript here tells that I is equal to 0 is because we are making the first iteration, the number of iterations. So, this is the 0th iteration, meaning the base value. Now, calculate the distance from each centroid using the Euclidean equation, just the simple equation. So, if the centroid from centroid, if the first centroid was chosen as 1 1, so the distance of this from that centroid would be obviously 0. For this, simplistically, it would just simply all you have to do is you have to subtract 2 from 1, square it, and plus 1 minus 1, square it, and then do a square root of the entire thing, which will give you the Euclidean distance of 1. Similarly, you do it for this and for all of the other values, and from the you calculate the distance from your second centroid as well. So, your distance, the second centroid, remember, is 7.57, right, because you were only told that to group the sightings into 2 groups, right. So, you have initially assumed 2 centroids based on the xy plane, and from the both of the centroids you are now calculating the distance in the second step. Okay. Once you have calculated the distance, you assume a minimum distance and assign data points to cluster C1 or C2 based on minimum distance. Say you assume a minimum distance of 2. So, this is some kind of criteria or threshold that you put. Now, if anything is less than 2, then you say that it belongs to cluster C1, and if the distance is greater than 2, then you say that it belongs to cluster C2. This is an iterative process. So, as long the iterations will stop once the centroid positions do not change. Once the centroid positions do not change between one iteration and another iteration, then you can say that yes, this is the centroid, these two are the centroids, and all the points around it belong to this cluster, and all the points around it belong to the other cluster. So, this is just the first iteration or the first step that we are telling you. So, if you assume, in this case, if you assume the threshold of d min to be 2, then you would say that in this case the distance from C1 is 0. So, since 0 is less than 2, this should belong to cluster C1. Similarly, all of this are less than 2. So, all of this are belonging to cluster C1, whereas all of this is greater than 2. So, this should be belonging to C2, right. So, that is how you initially assign the points to these different clusters. Now that you have assigned these points to different clusters, so C1 cluster has these 4 points, C2 cluster has these 3 points, then calculate the new centroid for each of those 2 clusters. Suddenly you had initially assumed 2 centroids, remember, now you have 2 new centroids, and if these 2 new centroids were equal to the initial centroid that you had assumed, then your iteration would stop and you would say that C1 and C2 are 2 distinct centroids. In this case, although they are not, for simplicity for this exercise, we are saying they are almost the same, although they are not really same. So, you have to repeat this for a next iteration, but for simplicity let us say that they are both same, because 1.375 and 1, let us say 1 and 1, we had assumed 1 and 1, I guess, and they are very close to each other. So, let us for this exercise say that C1 and C2 are almost the same, and we say that we stop the iterations here, and hence since we stop the iterations here, we find out that these 2 are distinct clusters, and since these 2 are distinct clusters and all the calls were between 9 a.m. and 6 p.m. in this cluster, so we can say that maybe this is an office location. 9 a.m. and 6 p.m. because these calls in this cluster came from 9 a.m. to 6 p.m. this could be an office location, and in this cluster all the calls came between 9 p.m. and 6 a.m. and hence this could be the home cluster. So, you see, now you have, based on just cell phone data records of that one ID, you have been able to decide that ID's possible home location and possible house location, and then you can further use mobile phone sighting data to find out the speed in which maybe this ID is traveling between these 2. So, you get an idea or you get a feel for how ITS or how cell phone data can be used in the transportation arena to find out not only activity, in this case activity locations, activity patterns, but in future also we will tell you how this can be used in calculating travel times and travel speeds. Hopefully, you are getting a feel for all of this. All the references are given here. We understand that many of you may not have a IT or a electrical or electronics background, but like we said, this is a new arena in transportation engineering and traffic planning. So, you should at least get an understanding of how all of this works. So, please do go through the references. In conclusion, in this slide, in this lecture, what we have looked at are the different classifications at vehicle, infrastructure and cooperative levels, the different ITS phases, what are user services, and what are architecture and how do we plan, and then we have looked at the 4 different components of efficiencies and how big data can be applied in finding out activity locations. Thank you.